The topic is direct variation, page 260. We have an example with a recipe for paella calls for 1 cup of rice to make 5 servings. In other words, a chef needs 1 cup of rice for every 5 servings. So you can see that if you increase each time the number of rice, the number of cup of rice, you are going to increase the number of servings too. You are going to represent, tell me.
What page?
260. So you are going to represent the change. And okay, we are not going to draw this because, okay, it's only an example. We are going to start with example 1, but I need to read with you the theory. A direct variation is a special type of linear relationship that can be written in the form y equal k multiplied by x, when k is a non-zero constant called the constant of variation. Okay, so we have k, and k has to be different from 0. Now for the example 1, identifying direct variations from equations. Tell whether equation represents a direct variation. If so, identify the constant of variation. What is going to be the constant of variation, guys? What we call the slope, right? The slope of the graph. This is going to be the constant of variation. So for the example A, we have that y is equal k multiplied by x. So what we need to change in here? What is the value for k? This is 4, right? Y is equal 4x. So what we can say about this equation? This equation represents a direct variation because it is in the form y equal k multiplied by x. So the constant of variation, what is? 4, right? Because it's the value of k. It's the value that is with the x. So this is the value for the constant of variation. Now for the example B, we need to identify this in the same way, looking at the equation. We have negative 3x plus 5y, let's say plus 5y, this is going to be equal 0. So how can I know if this is on this form of a direct variation? We need to find the value of y, so I need to isolate the variable. In the first part, we need to, okay, we have that 5y equal what? It's not going to be equal 0 because you pass, for example, 0 plus 3x is subtracting. So if you pass it to the other side, it's going to be a sum, is going to be positive. So if you erase the 0 because you don't need the 0, you have that 5y is equal 3x. And what is the next thing we need to do? The number 5 is multiplying my variable, so I need to pass it to the other side to divide. So for the value y, I'm going to have that this is equal 3 over 5x. So this equation represents a direct variation because it can be written in the same form, y equal k multiplied by x. What is the value for k? K is going to be 3 over 5. So the constant of variation is this, so this represents a direct variation. You already know how to find the value of the variable. I was only showing you, okay, to see the result. For the example C, you have something like this. 2x plus y is going to be equal 10. Again, what we need to do is to change the form of this, pass the variable to the other side. You have y equal 10, and this 2x that is in addition, I'm going to pass it to the other side to subtract. So I have minus 2x. What is the difference in here, guys? This is not the form we have in here. I only have one number multiplying x. I don't have any other number in addition or subtraction, like in the first one or the second one. So it doesn't represent a direct variation. This equation doesn't represent, I'm going to write it in here. This equation doesn't represent, I'm going to move this. Okay. Doesn't represent a direct variation. This, it doesn't have the form of the equation we need to have to be a direct variation. What happens, for example, if you solve, okay, I'm going to write in here. What happens when you solve this one? I think that you understand this because you already know how to obtain the slope. And this is going to be the same. It's like we have the slope multiplying the variable. And this is my form of the equation. So it's the same, okay? The constant rate of change is going to be the slope. And if you want to find what is the value of x, you pass the k, right? To divide. But you need to find, in this case, the value of this constant. So if x is multiplying k, you need to pass it to divide. So I want to write this. What you have is this one, sorry. The value for k is going to be the variable y divided by the variable x. This is what we have for this variable. Only to show you, they are going to show you only how to obtain the value of k. And you know that in a direct variation, the ratio y over x is equal to the constant of variation. Now we can go to the example 2. Before we go to the example 2, I'm going to make a pause, so I can be sure that you understand until this part. Now for the example 2, page 261, we need to identify direct variations from ordered pairs. In the first example, it was from the graph, from the equation of the graph. In this case, we have the table. I'm going to write all the values in here. This is for the A. Okay, so you have x, this is 1, 3, and 5. You can see that for x is increasing constantly. It is increasing the same. 1 plus 2 is going to be 3. 3 plus 2 is going to be 5. You are increasing the same number. And for y, we need to know 6, the first one. The other one is 18. And the last one is 30. So we are going to draw the table. I'm going to draw the table with you to complete this. You have something like this. I'm going to draw the other line. Then using this table, I need to identify. What can you see in this case, for example? 6, and if you add 12, you obtain 18, right? Is 18 plus 12, you are going to obtain 30. So it's constant too. You are increasing the same number. You can increase or decrease. The important in here is that you need to use the same number. In this case, I repeat, you are increasing 12. So this is going to be a, but I'm going to write it with you. You can use two different ways to find this. The first one, you can write the equation. If we write the equation, for example, what is the form of the equation? Y equal k multiplied by x, right? And what is the value of k? Remember the value of k, we just copy this on the other part. To find the value of k, we divide y by x. So we take any value, for example, 18 divided by 3 or 30 divided by 5, and you are going to obtain the same. So what is the value for k? For k, I have that the value is 6. 6 divided by 1, 6, right? Or 18 divided by 3 is
6.
6. 30 divided by 5 is 6. So the constant in here is 6. You can replace it in here. Okay, since the moment you see that you obtain the same value in all of this, you already know that this is a direct variation. But on the book, they want to show you all the steps, okay? But since the beginning, you see that this is increasing constantly. 1 plus 2 is 3, and 3 plus 2 is 5. In here, you increase 12 to each one. Since the moment you see this, you can say that this is a direct variation. But you can prove it. You need to prove it using one of the two methods. The first one, it could be finding this. Now I can write my equation. I'm going to replace that the value of k is 6, and I multiply this by x. Okay, and this is the form of the direct variation. Remember, this is the form of the direct variation. And the other part, the method 2, you find what we did in the first. Okay, to complete this, you divide each value of y by each value of x. So if you divide, for example, in here, 6 divided by 1 is going to be 6. If you divide 18 by 3, again, it's going to be, 6. And for the last one, if you divide 30 by 5, it's going to be 6. So you can see that you obtain the same in each one is a direct variation. And you know that you are going to obtain the same number because in each number of x, you increase the same. And in each value of y, you increase the same. So since the beginning of the problem, you know this. Only that you need to prove it, okay? Only that you need to prove it. So this could be the method 1. I'm going to write the number 1 in here. Maybe it could help you. And this is going to be the number 2. I'm having this space in here because I don't want to keep this together so you don't confuse with the 6. And for the B, we are going to do something very similar. B,
0.
tell me.
¿Y por qué puso en todas 6 al final?
You divide each one. The value of y by the value of x. 6 divided by 1, 6. 18 divided by 3, 6. 30 divided by 5, 6. This is the other method to prove if it's a direct variation. Okay? Now in B, I'm going to draw the other table. The values of x and the values of y. So for the first one, we have 2. The second one is -2. Okay, the third one is 4. This is 0, 8, and 4. Okay, since the beginning, what you can see, 2 plus 2 is 4. But you increase 4 in here, 8. Okay, maybe. Negative 2 plus 2 is 0. It is a direct variation because since this, you increase 4. It's like you have, for example, a 2 in here, and you are going to obtain, it could be a 6, right? If you increase 2, it could be a 6, and in here you can have a 2. Only that they don't write all the values, but I'm not going to confuse you. We are going to solve it, okay? What I'm telling you, that is going to be a direct, okay? Only what's in the table, okay? But we don't know for sure. Remember, if you include these numbers I write to you, you can obtain a direct variation. But if you don't have this, it's not going to be a direct variation. So in the book at the end, you have that it's not, and we are going to prove why it's not, okay? So I'm going to complete the chart in here, okay? I have to draw in here. This is the worst part of this when I have to complete the chart. Okay, but I think that you can understand it better in here, in this board. What we need to find then? Method 1, we need to write the equation. So if we write the equation, what is the form of the equation? Y equal k multiplied by x. It's like you have m multiplied by x, guys. Only that m, we use it when we have a graph. It's the slope of the graph. When we have a table, the most of the times we write k. This is the constant of proportionality when we have two ratios. And the method 1 is to write the equation. This is not a direct variation because it cannot be written as y equal k multiplied by x. And why, guys? Because if I divide, for example, the first one, negative 2 divided by 2, for example, since the moment you include this, negative 2 divided by 2, what value I obtain? I'm going to obtain negative 1, right? Negative 1. And when you divide the other numbers, 0 divided by 4, you are going to obtain 0, right? 0 divided by 4, you're going to obtain 0. And for the number 3, when you divide 4 by 8, you are going to obtain 1/2. This is the, I think that this is the most secure method to be sure about if it's a direct variation or not. You divide each variable y by each value of x. This is the form that you can be sure about this, because maybe when you're writing the equation, you can get confused. And in this case, you cannot get confused only dividing, okay? So I suggest you to use the method 2, because in this case, for example, it's easy to identify what is the value of k. But in this case, it's not going to be so easy because you have different values of k. The first one you have negative 1, in the other one you have 0, in the other one you have 1/2. So it's not easy to identify about this. So this is not a direct variation because y over x is not the same for all ordered pairs. You can see again, as I told you, they are not increasing in the same way. 2 plus 2 is 4, but now you add 4. You are not increasing 2 again. And in the last one, negative 2, you add 2, you can obtain 0. But in here, you are not with 2 again. You are increasing 4. So it's not a direct variation. It's not constant. You can see that the increase is not constant. So this is not a direct variation. Tomorrow we finish with the example 3. It's the last one, 3 and 4. And later you solve the homework. You already know what is. I give you the image the last week. Is the exercises from the guided practice 4.5. We always solve the guided practice. Page 263, but tomorrow we finish the last two examples, the number 3 and the number 4, about this. So I'm going to finish in here, guys, sharing this, so I can give you some time if you want to ask something about this. Okay, so guys, I need to know if you're understanding. I think that this topic is the easiest one. I think that this topic is the easiest one, so you are not going to have any trouble. I'm going to finish the recording, guys.